Today's episode is brought to you by Growing for Market magazine. For 31 years, Growing for Market magazine has been the source of practical ideas and information for direct market vegetable and flower growers. All articles are written by farmers who get their hands dirty and know what they're doing. If you do farmers markets, CSA, farm stand, pick your own, florist sales, or wholesaling, whether you're a commercial grower or want to grow like one, subscribe to Growing for Market for the nitty-gritty details of growing, marketing, and the business of small farming. Available as paper magazine and a digital download with thousands of archived articles available. Use the coupon code WORM, that's WORM, to get 25% off any subscription at growingformarket.com. Today's episode is also brought to you by RIMOL Greenhouses.
Whether it's tomatoes to market, flowers in the spring, or your family's harvest, growing in a greenhouse protected from the weather provides the right environment that you need for a harvest that you can count on. RIMOL Greenhouses are designed for durability and offer the quality that you need to grow productively year-round. Visit RIMOLGreenhouses.com to get a quote today.
If I may editorialize for a second, I own a RIMOL tunnel. I love it. We built it ourselves, and I really appreciated the quality of the tunnel as well as the customer service we received in the process, so make sure to check them out. All right, let's jam. Hey, you all, Farmer Jesse here. Welcome to the No-Till Market Garden Podcast, Episode 20, Season 4. So, as I mentioned on Wednesday's special episode, this will be my last official episode hosting the podcast and the last official episode of Season 4. But I thought I would end my run where it kind of all started for me, with Paul and Elizabeth Kaiser of Singing Frogs Farm. For several years before this podcast, I had been experimenting with all sorts of random no-till ideas, but it wasn't until I heard their episode on the Farmer to Farmer podcast that it really clicked for me, and I realized that I could do this style of agriculture on scale because there were other people already doing it and doing it successfully. So because Singing Frogs was such an influential part of my own adventure into this style of agriculture, that's where I wanted to end my run and in this season. Paul and Elizabeth are so amazing, and we spoke about all sorts of stuff in this conversation, from the carbon sequestration and nutrient density studies they have been conducting on their farm to climate mitigation and nutrient excess from things like compost. It's just a really great and nerdy conversation, and I'm so thankful to Paul and Elizabeth for their time and their inspiration. Like I said, this is my last episode, but it is not the end of our work or this podcast, not by a long shot. This podcast will continue in the fall with a few new hosts, people I know you will be excited to hear from. I will continue to produce and edit it and do the Patreon reads. I will still have a season of videos coming up as well, so I will very much still be around. And of course, we will make whatever we create all free and open to the public, as we always do. So if you appreciate our work and it helps you or it helps someone you know, please consider signing up to be a patron at patreon.com/no-till-growers. There are discounts there on merch and the Living Soil Handbook and events when we get back to all that. But at a certain level, or if you just bump up from one level to another, even $2 to $5 per month, you get a shout out on the show. So big shout outs this week to Mark Ball, Kristen Kropp, Emma Barber, Kai Kocher, Abby Nash, Celeste Lopriado, Melissa M., Ojai Roots, Scott Snodgrass, Lucas Brindle, Jacob Arthur, and Yannick LaPlante. I shouted out a couple people in there who bumped up their pledges or joined the Patreon after my announcement this week because you all are extra awesome. And I really promise everyone you're going to love what we have in store for you for Season 5. And also a special shout out to Jim Schultz, Kirsten Clement, William Hudgens, Brian Mariano, and Lou Voss, who have been Patreon members since the very early days in 2018. You all deserve an extra special shout out. You all are amazing. Thank you so much for the support, and big thanks to everyone who supports our work in whatever way that you can. Buying a copy of my book, The Living Soil Handbook, specifically from no-tillgrowers.com, is one great way to do it. You can also always just Venmo us a few bucks to @no-tillgrowers just to say thanks. Several people did that this week as well. Thank you to them. There are lots of new farmers out there who may not be able to swing a few bucks every month. Think of them. We appreciate all the support, and we'll continue to crank out awesome stuff for you, like this amazing episode with Paul and Elizabeth Kaiser of Singing Frogs Farm. Paul and Elizabeth Kaiser. Welcome to the podcast.
Fantastic, Jesse. Thank you for having us.
Yeah, really thrilled to be here. Thank you.
And I'm so thrilled to have you both. Obviously, Elizabeth, you and I spoke back in season 1, but I'm excited to have you both on to talk about singing frogs today. And, before we dive in, maybe you all could give us, sort of general rundown of the farm, where it's located and the acreage you're working on, and if there have been any significant changes since that last chat a few years ago.
Excellent. Absolutely, Jesse. So Singing Frogs Farm, we are a 8-acre property. We have 2.5 acres of intensive no-till veg, and we are truly no-till. We don't disturb the soil at all. We are located in Northern California, about an hour and a half north of San Francisco. We started farming here back in 2007. We did not start no-till. We, didn't really know what we were doing and started with tillage, and we're learning a lot, but very quickly moved in that direction such that by 2013, our entire operation was no-till, and our practices have been pretty consistent in those last 9 years. Absolutely. We're always interested in new information and have done a lot of tweaking, but that has been really exciting. So a little bit more about, what we grow and so forth. So we do intensive veg. We do grow year round. That's super important to us. We have about 45% of our produce go out through our CSA. Our CSA is weekly, April through Thanksgiving, and then Thanksgiving through early spring, we are every other week. And then we have 2 year-round farmers markets plus another seasonal farmers market. That's another 45% of our produce. And then about 10% of our produce goes out to a couple of restaurants and also a food hub. And that food hub is the only food that might go down to the Bay Area. So over 95%, probably actually over 98% of our food gets to the end producer with the end consumer within about 15 miles of our farm. And that's super important to us. Also, something that's a little on the new side, the last 3 years, we've started a no-till flower aspect, which has been really fun just to add more diversity out into our fields. And we've grown that every year. So last year, it was about 10% of our sales. And I personally have a lot of fun with that.
Yeah, that's very cool. I love the idea of integrating flowers into the vegetable garden just for the pollinators and for the beauty and all the things and the biodiversity in the soil. One of the things I want to focus, the conversation on today is on you all have been really good about doing research on your farm and on your practices. So I want to focus our conversation on that a little bit today, but I'm hoping I figure it wouldn't hurt for us to start by giving the listeners maybe like a basic overview of what your practices look like. Give us a description of your no-till systems.
Absolutely. So, our no-till system is very basic. We love the tenets of soil health. Disturb the soil as little as possible, keep as many green living plants in the ground as often as possible, a diversity of plants, incorporating animals and covering our soil at all times. So we always have that in our background of our mind, but we are just constantly growing in our nursery. Our nursery is super important. We do as many transplants as possible. And then every bed on our farm, we have 312 beds on our farm. Every bed on our farm will just constantly be rotated such that a bed gets anywhere from 3 to 9 transitions of different crops per 12 months. And that does not include intercropping, which is very important to us and I know is important to you also. But
yeah, with intercropping and multi-cropping, we really enjoy the aspect of getting those 2 or even sometimes 3 different crops simultaneously out of the same bed space at the same time, which really provides more soil coverage, more photosynthetic capture, and more root exudation, and therefore greater soil health, while also reducing irrigation needs by preserving more of the moisture in the soil. So we're really focused on maintaining that green photosynthetic cover over our soil at all times and ensuring that it's really an economic crop on top, not just a non-economic cover crop. We will do non-economic cover crops on rare occasion when down in our floodplains, and we don't want to have a harvestable crop down there during the winter floods. So that will be a non-harvestable cover crop. But otherwise, everything else is always going to be a green plant, photosynthesizing, protecting the soil, feeding the soil, and we're transitioning at a rapid pace. And you talk to our crew members, and they will agree that 99% of the work we do here is production, not maintenance. There's no going around with a backpack sprayer of organic sprays. There's not much weeding happening. There's all those sort of maintenance things. We set up a system to function at really peak performance so that we don't have to waste our time on the maintenance of thinning and weeding and spraying and all that. We're just focused on production. So it's really about turning over beds, transplanting, harvesting, turning over beds, transplanting, harvesting. And that's what we're doing 5 days a week.
Yeah. And so just to talk about the sort of bed flip, because that is a large part of the practice. It's really important for us to, have high management so that we know when a crop is coming out and we have the next, crop ready to go in. And so we are taking that the prior crop, getting it harvested as much as possible to the different markets, be that CSA, farmers market, restaurant, and then cutting it out at the soil surface. Then considering, do we need to add a compost? Do we need to add some fertilizers? Doing such, and then getting the next crop in, and flipping those beds from the one crop to the next as quickly as possible is super important for us. And there's a lot of systems behind that, including, keeping our nursery stocked and, knowing what is going to go into the next bed when we are ready. But that's the basics of our system. And we do have a new website up, and one of our goals was to get a lot of resources on there. So there's actually a video of us in stop motion transitioning a bed that a lot of people, thank you, time lapse, that a lot of people like looking at.
Very cool. Yeah, that's great. I will definitely make sure to point people there. And I also love that when you go to describe your no-till system, you kind of go straight to having it planted at all times. I feel like that's a lot of people focus on the disturbance and not necessarily on the photosynthesis. And I think that's the most important part, right? Is pumping those exudates into the soil.
Absolutely.
Yep. Yeah, that's what's really helped us build our soil carbon, and through having that high soil carbon with the high microbiology that it supports, honestly, that's really what helps us grow well.
And we'll watch as, a cauliflower crop ends or some other crop ends. If we don't remove the crop that day or the next day, if it sits there for a week post-harvest, that week, you see a lot of increasers coming in, all the weeds coming in, all the pest insects coming in. You see a lot of the things you don't want on your farm coming in that week post-harvest if the crop hasn't been removed. And if it's already been harvested but not removed, the photosynthetic capture is less and the soil cover is less and the growth has obviously been stunted or killed off. So you're really no longer having any benefits to the soil. So we love to see a crop once harvested, removed and turned over to the next crop that same day or the very next day. Keep things moving, keep things in sort of a healthy pattern of constant growth.
Yeah, I love that. I love keeping the nursery stocked and ready to, just on deck, ready to jump in the game whenever it's called on. Okay, so with all that in mind, I think we should get to some of this research because we have you've got a lot of different things going on. Maybe we can start with your community alliance with the Family Farmers Biointensive No-Till Demonstration Project. Maybe you can describe what that study was looking at, how it was set up, and then some of the findings.
Sure. And this was a collaboration. CAFF is a nonprofit that is strongest out here in California. It started in California, and it is a biointensive no-till demonstration project. And it was part study, but also they were really trying to get more biointensive no-till farms going, and then supporting those farms through doing, soil tests out there. We had them come through our farm to do workshops and so forth. And so they were interested in, how much carbon was being captured and how, and then also how that looked long term. And they were finding, on our farm, what we ended up doing is we tested our oldest no-till beds, which were in this study. They came out each May to test. So those beds were 9 years old, 10 years old, and 11 years old. Right now, those beds are 13 years old. And then they also tested, they said, we want your best field and your worst field. They tested one of our most challenging fields, our newest field, BLN, which was 5 years old, 6 years old, and 7 years in no-till production. It had been in tillage prior to that. And then we did a control also. And I will have to say that the control was right over the fence, neighbors of ours who gave us permission. It's perennial grasses, and the soil over there is actually quite good. It was disturbed when they tilled. They wanted to put in a vineyard 15 years ago.
Yeah, tillage was 20 years ago.
15, 20, we're not even sure.
They basically do one mowing a year.
Yeah.
So all the biomass that's grown there stays there.
Yeah, so that was our control. It wasn't like our control was a conventional farm or something like that. But they found that we had really good carbon acquisition. They found, at 0 to 15 inches in depth, we had 6% carbon, which comes out to be soil organic matter is about 50% carbon, so that's about 12 to 13% soil organic matter. Down at 15 to 30 inches, we had 3.8% soil carbon, or about 8% soil organic matter, and then 30 to 60 inches, it was 1.5% carbon, or 3% soil organic matter. And this really matched a lot of the tests that Paul and I have been doing over the years, not necessarily looking at soil carbon, but soil organic matter. And we've watched over the last 14 and a half years as soil organic matter really transitioned from 2.4% when we were doing tillage our first couple of years up to the 8, 10, 12% range once we really got into doing no-till for several years. And we've always believed that that's a really wonderful place to be. They say that our ag land in the United States used to be 6 to 10% soil organic matter, and I honestly believe that level, and I will say that's important, but even more important is the biology, and the biology that it supports and is a part of is really sort of a golden spot. And if that's what Mother Nature had in her fertile land, obviously she knows things, and there's balances in there and so forth and so on. So looking at just how much carbon we had, it really mirrored the tests that we had been doing over the last dozen years, and that was nice.
Yeah, we had already looked at the top 3 feet of our topsoil, and we had done sampling every 6 inches in the top 3 feet. And we had the same results that the CAFF study did, which was great. And that basically showed that we went from sort of a 10 to 14% organic matter in the top 6 inches to a 2.5% organic matter in the bottom 6 inches of that 3 feet of topsoil.
Right.
And honestly, that 2.5% organic matter 3 feet down is the same level that we used to have when we were tillage-based at the surface. So our surface soil, when we were tilling, is now how good our super deep subsoil is being no-till. And everything above that super deep subsoil is phenomenally better. It's been quite a transition.
So they gave us different ways of looking at it. Also, another one of their numbers that they came up with that our good fields had 60 to 70 tons of carbon per hectare versus the control had 20. And when you look at various different studies looking at ag land either around the world or specifically in the United States, our ag land in the U.S. is sort of labeled sort of 10 to 20 tons per hectare. So all of that, again, sort of fits the same picture. One thing that was really different was a test that's somewhat new and people are still trying to understand. It's called POC, and that really looks at labile versus stable carbon. And this was huge, labile. This was huge for us because for several years people were like, yeah, it's great, you're sequestering carbon, but is it just going to, go back up in the air again, or is it stable? And they found that the majority of our carbon was stable. And
stable, long-term, permanent carbon was being built here in this soil.
Yeah, so that was really exciting for us.
Yeah, that's so cool. I also, one thing you touched on, Elizabeth, there was this sort of balance between the soil organic matter and the biology. And I sometimes hear people say like the soil has a limit of like how much carbon it can bring in, and the sort of soil saturation argument. And I'm always like, but when it reaches like its limit, or as it reaches its limit, it's putting a bunch of that biology in, or a bunch of that carbon into biology, right? We're carbon-based life forms. So like, I mean, does that ring true for you, or is that like that idea make sense?
Absolutely, it does. In fact, Ray Archuleta was out here, pretty renowned soil scientist, originally from USDA, now private consultant. But Ray Archuleta was out here looking at our soil and doing his own tests, and he said the soil respiration rate was off the charts in a positive way. He said there's so much biological life, and it is so active in the soil that, yes, we've been sequestering this heavy, permanent, long-term carbon in the soil, and the biology, therefore, is having a field day. The biology is thriving because of it. So the soil just becomes that much more vibrant and alive. And it's on the order of a healthy, temperate forest floor. So
yeah. Talking again about, the stable, the stable carbon and the biology in there. Another test that we did a couple of years ago, and we were really a little on the concern side doing this, was the Slake Test. The Slake Test is where you take a chunk of your soil and you put it in water and you see how it holds together. And it's the super molecules, the glomulins and so forth that the biology secretes to create, aggregates to create the ecology in which it will, thrive, that holds together those aggregates. Now, we have a sandy loam for most of our soil. And so we've had people come out here and be like, oh, yeah, there's not much aggregation out here and, so forth. And so we were like, oh, gosh, do we have it? Do we not have it? And
because it's so originally sandy, and now it's really earthy, it's like chocolate cake sort of, it's still crumbly in the hand. Like you dig down 6 inches and it just sort of, you can barely get a clod out of our soil. It's really hard to get an actual clod,
right.
And you're being very gentle and ginger with it because it might fall apart. And then we went next door to a neighbor, and they're doing tillage and cover crops, and we had to chisel through their hard, compacted soils to get a very easy clod out of their soil from 6 inches down. And so theirs was like a rock. It was like a piece of concrete. And ours, we had to gingerly carry it so that it wouldn't fall apart. Put them both in water to do the Slake Test. And ours at first floated because it had so much air held in there by the ecology created by the glomulins, by the biology, that it actually floated briefly before sinking down, but not a single molecule of soil fell off of it. It was so fragile to carry, and yet it was all held together in these aggregations by the biology and the excretions of the biology. That piece of concrete from the neighbor, put that in the water, completely turned to silt in a matter of minutes. It was gone. The rock was gone. It had just dissolved into silt in the bottom of the container. And for days afterwards, our soil still sat in the water, not having shed any soil molecules at all, but being held together entirely by that really super active soil biology.
And I love this test because unlike, some of these tests that I'm talking about that have to be done at a university and so forth, anybody can do this test. Just look it up real quick online and you can, get the basics of it and, try it with your soil and try it with, a neighbor's soil, or if you have a tillage patch and a no-till patch or whatnot, it's fun to do.
Or even just going over to your fence line and go to the fence line where you haven't been able to till or grow or do no-till. But fence lines tend to harbor some pretty decent soil and decent weeds, and get some soil from there and compare that with your field soil.
I love that. That's great. A couple things in there. One, the respiration note was really interesting. Like this becomes really important, especially in your situation where you have the beds planted at all times. So, in a situation where you create really good soil after a while and then you leave it unplanted, you're losing all that carbon dioxide that's coming out of the soil that your plants would be utilizing for photosynthesis and putting back into the soil. But by keeping it planted at all times, you're basically not only maximizing that soil respiration, but also creating better soil respiration.
Absolutely. Absolutely. And it's also one of the reasons at this point, we don't see adding compost to our bed as a way to build our soil organic matter. At this point, adding compost to our beds is to feed the biology. And they're eating that up.
And that transition happened probably in year 4 or 5. It was pretty early on. It's only the first 3 years where the compost is really seen as helping to build soil. And since year 4 or 5, the compost we've backed off way to a very small amount of compost. And its intention is to make sure to feed soil biology.
Right. Up front, Anyway, let's talk about compost a little bit later. Let's continue on with this right now. I'm going to also in the CAFF study, another thing that was really interesting I found, we were not the only farm that was studied, and they wanted to look at what the effect of no-till management was over time. And they also included actually some friends of ours, Hillview Farms. They're up in the Sierra foothills. This is Michael and Shannon Whamman. And they have a wonderful biointensive no-till market garden up there. And they, at the time of the study, their new farm was 2.5, 3.5, and 4.5 years. So average of 3.5 years. And I think I showed this to you, and I'm going to put it on our website also. But what it showed was both that the longer that the farm implemented the no-till practices, the more there was carbon increase. And I think even more exciting than that was that the rate of carbon accumulation increased. I mean, it was a bit of a J curve. And I was really excited about this and sort of thinking about it. And I realized it's not actually all that surprising, because if you look at other studies, if you look at like the Marin Carbon Project or the work of Dr. David Johnson, they all talk about, you know, the biology getting to a point where you have a state change and all of a sudden it starts to take over. And I'm curious if the similar sort of thing is happening there. I mean, in the Marin Carbon Project that was done years ago now, where they took a very biologically active compost, and on some rangeland, they took 1 acre or some set amount and just put a centimeter of compost on it, top applied once, and then they tested the carbon, and they found that from prior, you know, it actually losing some soil organic matter due to poor practices, just that one change, just that one application flipped it, and it started to increase in soil organic matter.
So that it increased organic matter every year for the next 10 plus years, even though the compost was applied only that one time.
Wow.
And so I think, just to reiterate the CAFF findings here, CAFF's findings on our farm and the other farm, Hillview, was that not only are we adding more and more carbon each year, but the rate at which we add carbon increases each year. That is a remarkable thing. And that's where it goes back to how she said the biology. Because we've had this state change in the biology and the health of the ecosystem of biology in the soil, we're not just adding more carbon each year, we're adding more carbon than we did the year before, and more carbon than we did the year before. And so the rate is increasing every year.
Yeah, at least for those first few years. Yeah. So this was looking up through 11 years.
Yeah, that's amazing. And also there's something about this too, where it's, you all are actively engaging with your soil. You're clearly, you know, putting crops in and taking crops out. You're testing this against the control is basically just being mowed once a year. But when you look at the control numbers, there's like an inch up, a little bit of a, you know, slight tick up of carbon, but not like nothing in comparison to what you're doing. Where my mind goes is this idea of like, you're engaging with the soil and you're actively, you know, like you're putting soil, you're stewarding it, so to speak. But then you have this other plot that's kind of left wild in a way, and it's not having the same rapid carbon increase. Does that make sense? Do you feel like that is an observation that you've made or that you feel is accurate?
Absolutely. In fact, the control, as we said on the CAFF study, the control was not actually our soil. It's over the fence in the neighbor's field. And we only farm 2.5 acres of our total 8-acre property. But me personally, I'm still in love with the other 5.5 acres of our property. And it is a really strong concern of mine to manage the other 5.5 acres as well for optimal soil health, despite the fact that we're not doing intensive vegetable production there. So I really focus on maintaining our grasses in a way that helps build soil, and maintaining the clovers and maintaining other trees and shrubs to really grow soil health throughout the entire 8-acre property. And that's just more of a pet love, I guess, because it doesn't really...
You love soil and you love life.
Yes. Well, It doesn't benefit the 2.5 vegetables, and therefore it doesn't have an economic return. But what it does do is it does help with overall water infiltration during rain events and water holding capacity, and therefore water use efficiency. And it helps to recharge our aquifers and recharge our topsoil banks throughout the entire property. And so it helps everybody, it helps our entire farm and everyone downstream of it.
Can I just ask what that management looks like? I'm curious, like you said, manage the grasses. I'm assuming you allow them to grow a little bit and then maybe you're trimming them really high, like almost like grazing them, or are you grazing them? What does that look like?
Yes, good. So it's a combination of either grazing. We have some permanent pastures, we have some temporary pastures, and we have some lead ropes that we can stake out goats on, and then we have the weed whacker. Because none of these areas are flat for mowing. They're all very undulating little pieces that are full of character, so to speak. And so really, yes, what it means is maintaining the grass and clovers, really getting as healthy and diverse of a mix of plants into those meadows as possible, but then maintaining a minimum of about a 4-inch height and a maximum of about a 12 to 16-inch height. When the grasses get over 12 or 16 inches tall, they begin to lignify, and the base begins to get stiff and woody because it's going to put on a seed head, and therefore the growing head of the grass begins to lengthen up the shaft higher and higher. So if you came in and grazed it or cut it, you would be cutting off the growing head, therefore killing the grass until it reseeds until the seeds grow the next year. So if you let it get too tall, you risk cutting off the growing head and therefore killing the grass. Likewise, with the shorter height, we don't want to go under 4 inches in height, because under 4 inches in height will begin to allow sunshine to get through the grass and hit the soil, drying it out. And we've noticed that if we cut grass down to 2 inches or 3 inches tall, without any rain, that grass is going to die within a month or two because of drying out. But if we keep it 4 inches high or taller, we can keep pretty much green grass on our farm 12 months of the year, despite these California 8-month dry seasons. And so at the end of an 8-month dry season, we still have green grass throughout our pastures, not vibrant green grass, but it's alive and still green and growing because we've kept it tall enough that it shades its own roots and feet and soil. So having that sort of 4-inch to 12-inch range for our grass heights is really critical, plus having all kinds of understory clovers and plantains and other native herbs.
See, that's great. I mean, I think the implication of my original question there was just that sometimes there's this concept that humans shouldn't be engaging with the soil. Like the wild would be better left alone. And I feel like studies like this kind of suggest that with a little bit of management, or the proper management, it demonstrates how much good humans can do, or how much carbon we can sequester, and how much life we can build. Do you feel that way too? I
think that, a lot of the idea of leave it alone, get humans out of it. Humans haven't been out of it. Humans have been a part of, managing systems. And we need to recognize that. So I also...
So yes, I agree. We can have a lot of positive impact on otherwise natural systems in helping keep them, quote unquote, natural in their functioning and their appearance, and not pillage them for their resources. But we can do a better job of enhancing that and really helping it thrive than if it were entirely left alone. In part because as humans, we've removed so many other competing species of large mammals, and that has really changed the demographics of animal populations on rangeland. And we need to come back in and help fix some of those problems that we've created through wiping out coyotes, wolves, mountain lions, bobcats, wolverines, etc.
Elk.
So,
yes.
Yeah.
I also wanted to take it in a slightly different way, where you are talking about look at the control and how much, carbon and presumably life is there, and, our actively managed no-till beds. And we did some PLFA, which is a basic biology test years ago that I think are very similar to what you might be getting at, Jesse, where we looked at the PLFA tests from inside our actively managed beds, and then also in the roadway, which Paul manages by keeping green grasses and mowing or having animals on. And we found that the PLFAs in the beds were multiple times higher with the biology. So the beds where we were, having a crop go in, come out, we were taking resources from those by the harvest of the vegetables, those had significantly higher, help me by the numbers.
Well, so like the roadways where we're just traversing and walking and driving the tractor with the compost bucket, those were still above average for soil biology. They were still very healthy. And then you get into the actual beds where we do production, and we often had 3, 4, 5, or 6 times as much soil biology. And to know that our control being the roadway for our biology tests was already above average, it was already very good. But to look at the production beds, the actual places that we're extracting our economic livelihoods from, and to know that the biology there was 4 to 5 times greater, shows that the way we were doing no-till was absolutely successful.
That's great. Hey, you all, just jumping in here real quick to get a word from our show sponsors. Today's episode is brought to you by Tilth Soil. Tilth Soil, this Cleveland, Ohio-based company, is producing some of the highest quality soil mixes out there. That's why I included their work in my book and use their products on my farm. This is true. Tilth Soil makes composts and potting mixes approved for use in certified organic operations like my own. Their living compost is made from food waste they haul and compost themselves, and it is the cornerstone of all of their blends. Tilth Soils take regenerative and organic growing to a new level. For more information on their products, including bulk ordering and their nationwide shipping, visit www.tilthsoil.com. All right, back to the show. Another thing that I'm thinking about with this study, getting back to the CAFF study, is, there's talk about whether or not agriculture can be effective in mitigating climate change or being, working towards sequestering carbon and all those things. Studies like this kind of give me some, should give people or give myself some amount of hope or something to look at, to point at, to say this is what it does. This can be effective. I mean, do you have any thoughts on that?
This can be effective.
Absolutely, because often forgotten is, we point our finger at fossil fuels for greenhouse gas emissions, the climate change, and all that. But we really need to look at the scientific numbers that are demonstrating that we have already lost over 70% of the planetary soil carbon in the agricultural lands around planet Earth. 70% of soil carbon is gone from our ag topsoils. That happened in just the past 80 years of mechanized tillage, which means we don't have another 80 years of topsoil. We have already burned through more than 2/3 of our topsoil's carbon in just 80 years of growing humanity to where we are now. We absolutely need agriculture to be the solution. It's not just that it can be, it must be the solution.
Yeah, and I think there's many, many, many different solutions within ag on larger scale, on smaller scale, and so forth. One of the things that I really like about the biointensive no-till and doing it on a small plot of land is that I think it's accessible to many people. It's accessible to a lot of young people who don't have access to large tracts of land within the United States. But also when you look globally, most food in the world is not produced on large tracts of land. What is it? 60 to 70% of the world's food is produced by small, growers on 2 acres or less. And we don't see that in the United States. And also those people who are on small acreage and farming that, they're more often, people of color, they're more often women, and they're more often taking care of it in ecologically beneficial ways because they live on it and because they have, a smaller farmer footstep. They're actually seeing it. And if they have to use something negative, they have to live with it. It's right there in their face. They're not plugging it into a computer program and it's one of 1,000 acres, right? And so that's obviously we love what we do, but one of the places that I see that I want to be a little bit of a lighthouse because yes, it is a solution.
So we actually, because so much of our passion right now is actually on fighting climate change and food insecurity and social justice, racial justice, et cetera, and equality, one thing that we have gotten to be a part of is the farm school.
Right. And the Terra.do is an international climate school, not necessarily farm. It's an online program. But one of the things that has started to happen in person is there was so much interest in ag because of the positive solutions that ag can have. that they have started to have climate farm schools. And last year we started with 2, one in Washington State and one here in Sonoma County that we were a part of. And then this year they're also starting those, they're continuing those 2. We'll be hosting one in April and then another one in July and another one in late September. But there's also going to be one in Italy. They're starting up at least one in India, and they're hoping to roll that out to other no-till farms, bringing people in and training people. And so we're excited to be a part of that. And there's links on our website, and you can also just look up terra.do Climate Farm School.
That's great. Yeah, I think those are excellent. I would really love to see, maybe this is just like a personal feeling, but I see a lot of energy and money going into climate awareness, and I think that's really great and important work. But I also think that we need more ways to get it directly to farmers who are doing this work. So I think that's really cool.
Right. And I think just, getting farmers on or getting people on farms and getting farms connected, all of those things, which obviously, Jesse, you do through this podcast, virtually getting farmers to talk to other farmers. That's what we need to do, to share what is possible, what is happening in your context, and, how can I apply that on my farm or in my context or my life.
Yeah. And that's really the genesis of this podcast, was just seeing that we needed that information and just going and just deciding that we need to go get it. We need to go find it out. So that's great. And I appreciate everybody that's sharing.
Another thing I would love to talk about is nutrient density. My background is actually in public health before coming to this farm. And as we were starting it and learning, I was the off-farm income as a public health nurse. And we were approached we were approached 2 years ago by David Montgomery and Ann Bickley, who have written a couple of really good books into regenerative agriculture, and they wanted to take the next step. And I'm so thankful because so many people are interested in this, looking at regenerative ag and nutrition. And it makes sense if we have higher carbon in our soil, if we have higher biology in our soil, and we have higher nutrients in our soil, that all of that can hold. Therefore, we should have more nutrient-dense foods if it's grown in a regenerative way.
And that was always the assumption, and I think it's a good assumption to have because it makes sense, but it didn't have any scientific basis yet. There have been very few small studies here and there, and they've all pointed to supporting that assertion, but they wanted to do their own studies as well and see if it pointed to that assertion or not. And we were thrilled to be a part of it. Yeah,
so they reached out to a whole slew of different regenerative farmers, everything from dairy, wheat, soy, corn, legumes, and then they also wanted to do vegetables. So in terms of vegetables, they reached out to 2 no-till farmers, ourselves, and then also Brian O'Hara up in the Northeast. And with all of the farms, what they tasked us with doing is finding a non-regenerative counterpart in our area, same climate, same soil, that was growing the exact same crop, and even if possible, if we could grow it out from the same seed. So we found another farm. Ours is the only one in the study where the comparison is an organic farm because we weren't able to find a completely conventional farm. Some friends of ours who do a really good organic but tillage-based operation. And we said, whatever crop you want to grow. And they said, how about cabbage? Here's some seed. And so we grew out the same cabbage. It was a little late in the year. I was a little concerned. We harvested the cabbage last week of November. And the results were really stunning. First of all, we also did soil tests. That's when they brought out Ray Archuleta to do a really in-depth test of our soil. And what we found, first of all, with the soil studies, was that our soil had higher soil organic matter, had higher nutrition in it in terms of the nutrients in it and the biology. We already mentioned that Ray Archuleta was really excited about not only the quantity of biology that we had, but the respiration of the biology in the soil.
Yeah, I think our organic matter was 5 or 6 times higher.
Yes.
And the soil respiration rate was also significantly higher like that. And the water infiltration rate was off the charts, 10, 20 times more rapid infiltration. So overall, the soil health score between the 2 farms was very different. Theirs was on par with good organic tillage-based farms.
Yes.
And ours was sort of off the charts for that no-till regenerative farms.
Yeah. Well,
and then the question was...
They used the Haney Test, which we had used once before, and I do think is a great test because it looks at, what the nutrients and how they are able to be used by the organism. So instead of using really strong acids to deteriorate it, they'll use acids of the exact same, level that the biology would use. And
so it looks for biologically available nutrients.
Exactly.
It's really a more appropriate real world kind of test, the Haney test.
Right.
And so we got the health scores back for the soil. And then the next task was obviously to grow out the cabbage and then send the cabbage to a lab at the same time. So I had spent that day harvesting cabbage from their field and our field, boxing it up and shipping it off to the lab.
Yep. And some of the studies were, some of the macronutrients like vitamin K was 41% higher, vitamin E was 70% higher, some of the vitamin Bs were over 100% higher in our cabbage, vitamin C was 20% higher. But really where the biggest difference was in the phytochemicals, the phenolics, the phytosterols, the carotenoids. The phenolics and the phytosterols were over 100% higher in ours, and the carotenoids were 48% higher. And these are really the compounds. They are the ones that aid our immune system, that protect our DNA from damage. They decrease inflammation, regulate hormones. It's what the plants are using themselves to be strong and resilient, and it's why our plants are doing really well. And then obviously those benefits are being reflected to us when we eat them.
That's great. I mean, the conversation just about nutrient density, I'm glad that it's evolving because it did feel there for a while that we didn't really know what it was. Like we didn't know really how to measure it or monitor it.
Right. The tests are hard to do. So all of this research and also that from the other 9 farms that ended up going all the way through the study are coming out in their book, What Your Food Ate. And I think it's coming out this May or June. So we're super excited about that. I'll also say they also just tested out of interest, some of our carrots and spinach versus USDA standards. And, they came back with flying colors. I didn't get very specific ones, but they said 100 to 400 times higher on the basic nutrients. So, that's exciting because we feel that, growing in good food, in good soil, we know those veggies are nice and tasty, and we know that taste, is reflected in nutrient density. But it's nice, yes, to have some of that data.
And it's an important point to make that because you're building up these phenolics and phytosterols and all the other complex compounds of real, true plant health in the plants, yes, of course, us humans eat those plants then and we get more of that nutrition as well to make ourselves healthier. But think about it from the plant's point of view. You've just made much healthier plants. Well, healthier plants don't need all the maintenance that most farmers are used to giving. They don't need side dressing. They don't need all the weeding. They don't need pest protection. They don't need to have compost teas sprayed on them. They don't need to have other organic sprays put on them. They're just stronger plants from the beginning. And this goes back to our point that our farm is really focused on production-oriented tasks every day. We don't want to do maintenance tasks. They suck. They're not fun. They're just maintenance. They're not actually getting any bang for their buck. And so if you can create a system of true regenerative health, you've created plants and soil that are so resilient, they don't need you to come in there and do all these maintenance activities and tasks to help them along and keep them going. They're thriving on their own. You just got to keep the system going. That's really what our goal has been. It's been really an amazing success.
Yeah, that's so cool to hear. The thing you mentioned like maintenance tasks, and I think of things like putting over row cover, and you also mentioned that, insect netting, those sorts of things. Like, are you seeing in your own fields a significant decrease in those sort of issues and sort of, especially since you started out more as a tillage farm, like over the years, have you seen a rapid decrease in the amount of pest populations?
Yes, absolutely. The pest populations are way down. When we were tillage-based, it was ridiculous how many hours we spent on pest management and pest control and vacuuming and sticky traps and hand picking and all that. And we don't do that at all anymore. For 10 years, we haven't done pest management in terms of the insect pests. So ironically, we would be using far fewer row covers and insect covers because our general farm agricultural pests are way down. But because we have focused on really growing true ecological health, a different kind of pest is way up, which is all the songbirds and the deer and all the animals that love living here. And so we do use a lot of insect covers and row covers just to keep all the songbirds off. And that's only for certain crops, because obviously they only like certain crops during certain times of the year. So songbirds will love the young brassica plants all through winter and early spring because the brassica plants have a certain array of amino acids that the songbirds need those amino acids in order to put on mating plumage in January and February and March. So we know that the songbirds are going to hit our brassica seedlings in November through February, that kind of thing. But I'm happy to have that as a pest. That's a wonderful pest to have, hundreds of songbirds flitting around to the hedgerows in the fields while you're out there working.
Yeah. And just, talking about the pests and the reasons that we don't have them, yes, we've got more healthy plants, and that definitely helps the plants have their own immune system and are fighting them off in various different ways. Also, that soil biology, let's remember, when you have a robust biology in the soil, a lot of those are predatory. And a lot of your pest insects will have part of their life cycle, be it the eggs or the larvae, in the soil. And so the healthy soil biology definitely helps cut that down tremendously.
It devours the pests.
And then in our last episode, Jesse, in 2019, we talked quite a bit about hedgerows and ecology. All of that, yes, brings in the birds that Paul's talking about, and also brings in all your beneficial insects, which are keeping those in check. So yes, our main pests are birds and unfortunately gophers and a little bit deer.
Yeah. What about the one that always comes up that people always ask me about is flea beetles. Has that been something you've seen a reduction in?
No.
The flea beetles for us are a unique challenge because upwind of us sort of is a 150-acre conventional vineyard. And
our next door neighbor,
their cover crop is, their winter cover crop is mustard.
Yeah.
And flea beetles overwinter in mustard as their hibernation source. So when that mustard gets mowed in late April every year, we have this flood of 150 acres of flea beetles looking for a new home, and they descend on our farm. So we have no flea beetles from August until April. And then once they plow under the cover crop, April through about July, we are inundated by their flea beetles.
Yeah.
So it's a problem that their monoculture has caused.
Right.
But
and
without them, we come into balance by the end of the year.
Right. Our ecology does balance it. It's just for those few months. Our ecology, the equation is too overbalanced.
150 acres of theirs monoculture versus our 8 acres of ecology.
And so we love the Protect Net. And we will put that over especially all of our mustard crops, our bok choys, our Napa cabbages, and so forth. So that is actually sort of the one exception.
Right. Yeah. I mean, that makes sense. It's funny. I was thinking about this when you were talking about how healthy your roads were, because I probably talked about this on the podcast, but I always think about drift and like how when you are a conventional farmer, whether you're spraying chemicals or whether it's even just like something like that, where they're mowing a cover crop that's having an effect on you, there's a drift from that sort of mindset or of that sort of conventional agriculture. But like in your pathways, there's probably a drift from, hauling compost around or just like not, over managing those areas. So that's why those roadways were actually, like you said, even healthier than most around. And like you said, managing your grass. I don't know. That's a thought that just kind of popped into my head when we were talking about this.
Interesting.
Yeah, no,
Sure.
I've definitely, we get a lot of compost spillage from wheelbarrows in the roadway. You get a little bit of water scattered here and there once in a while, but mostly we've put a lot of effort into invigorating some of the more native herbaceous perennials and herbaceous weeds in those roadways, as well as adding in clovers and grasses to create real diversity so that there's something blooming in our roadways 9 or 10 months of the year. And there's always a handful of things that can survive even the worst of droughts through without any water. And then obviously the managing with mowing elevations. So it's really a lot of management and a lot of know-how mixed in with just, yes,
And
amongst our field.
the microbiology does not stop at the edge of the field.
No.
Your beetles are going to walk over into the clover in your roadway, and the mycorrhizae are going to reach out into the roadway.
And likewise, many of the beetles and spiders who help with pest control live in the roadways.
That's true.
And they come from the roadways into the vegetable beds to help with predate on pests.
Yes.
So one of the things that also just like in thinking about, questions that I get a lot, like the flea beetle question, but one of the questions I get a lot too is about nutrients and nutrient excess and nutrient leaching, specifically with phosphorus and nitrogen. And I know a few years back you all did some studies on that. Do you have any thoughts on that, or can you maybe talk a little bit about those studies that you did?
So compost is a very potent thing. It's a great thing. We love compost, and you can have too much of a good thing, can't you? And this is why I don't, love the terminology that is sometimes used of deep compost for, some of our methods, because we want compost to be seen as one tool in the toolbox. And, you don't want to start off with 4 inches of compost on something. Compost can definitely, if you don't have the biology there or the carbon to hold the nutrients, you're going to have runoff. And we, early on, when we were first starting to really share what we were doing, we had some people who were very skeptical of us, and they came out here and they were like, "Oh my gosh, you're using so much compost. You are absolutely, polluting your waterways." And that really had us concerned. And they were concerned about nitrates. We were talking to another farmer who was getting pushback from some agronomists that were more concerned with phosphorus. And so we said, great, we really don't think we have leaching. We are Singing Frogs Farm. We have 6 ponds, including at the bottom of our property. We don't have algal growth in our ponds, as you'll sometimes see on farms when they have runoff. We have crawdads, we have turtles, we have river otter in our ponds seasonally, but they weren't going to have any of it. They're like, you got to test your water, you got to test your water.
Yeah, we've visited organic farms on farm tours with conferences, and those organic farms have holding ponds with 6 to 12 inches of frothing green algae on top of the water.
Yeah.
That's nutrient runoff. That's nitrogen leaching. It's awful to see. We don't have that. We don't have algae growth in ponds, but they were concerned. They were people that we respected, so we did tests. We did water tests. We tested the rainwater falling down. We tested the well water coming up, and we tested the water running onto our property from our 2 neighbors uphill of us. And then we tested the water throughout the fields all the way down to the bottom to our 2 seasonal ponds, which collect all water that falls on the farm. They end up in those bottom seasonal ponds before they leave the property.
Our farm actually happens to be a perfect experiment for this, because our entire farm is at a slope, and then it sort of bottoms out with our seasonal ponds there.
And it's got a good clay layer below it with only 6 inches to 2 feet of topsoil on the clay.
Yes, so we're very lucky with that.
And so we tested the water from top to bottom, and we found that our own composting area, we have a catchment pond below that, and that catchment pond, as we assumed, had higher levels of nitrates. It had about 6.5 or 7% parts per million, about 7 parts per million nitrates in that catchment pond below the composting area. We also had a neighbor who at the time was doing a bit of a marijuana grow up in a forested ridge above us, and directly below that we had about 7 or 8 parts per million nitrates coming into our property as well. I'm assuming from their nitrogen fertilizers. And so those were 2 sources of nitrogen run on. The rainwater and well water were, of course, clean, stuff like that. But then we followed the water through the farm, and we went down into the beds and dug into the beds and found standing water in the winter. We test that water. We go to the seasonal ponds, test them. And we found that as we moved through the farm from top to bottom, that nitrogen level got less and less. In fact, almost immediately it went from the 7 and 6 parts per million nitrates. In the first field, it was down to only 1 or 2 parts per million nitrates. And by the first seasonal pond, it was down to half a part per million nitrates. And by the final seasonal pond before leaving the farm, it was undetectable. No nitrates in the water.
And to give you a little bit of context, according to the EPA, 10 parts per million is what's considered safe drinking water. So it wasn't something to be concerned about, but it was there and we were able to see
it. It was a very low level that's not even considered a pollutant. And our farm absorbed it all. The farm left the water cleaner than when it came onto the farm. And the phosphorus,
is less of a story.
lots of a story, but the phosphorus we found was completely uniform throughout the whole property, whether it's water running on or the water leaving or the water on the farm, it was all the same levels. So we weren't losing any phosphorus and we weren't absorbing any excess that was running on. But the nitrates we were absolutely absorbing any excess nitrates coming onto the farm and putting those to use in our fields. Grow food.
And I don't want this to be, oh, don't worry about it. See, on Singing Frogs Farm, it wasn't an issue. We were very worried about it, and I would like to instill in people, don't throw on a ton of compost, and
right,
then let it
rainstorm.
Exactly, or a flood or something like that, because there definitely is the potential for that leaching, and that can be a very bad thing for groundwater, for surface water, and losing your nutrients.
So it's really building up your whole system together. And you got to test your water, test your soil, test to know what is going on and to make sure you're not moving too fast with one part and the other part hasn't caught up yet. So you don't want to put on compost fast and you build soil biology.
Right.
But you don't want to put on compost so little that you can't build soil biology. So it's finding that balance and bringing it all along together so that you are increasing the whole system's capacity and functionality sort of simultaneously rather than leaving any parts behind.
Yeah, that's great. So one thing you mentioned there was testing and monitoring. What does that look like for you? Are you doing yearly soil tests? And then are you coupling that? Like, are you doing the Haney test? Are you doing yearly soil test? And then are you coupling that with fertility management, adding nutrients? Like, what does that whole sort of fertility management program look like?
Sure. So the Haney test is very new. I think it's been around for 3 or 4 years maybe. And we love it. It's got about 40 different aspects to it that all combine to give you a soil health score. And understanding all the aspects of the Haney test can be challenging, but once you begin to understand it, it really is, I think, by far the best soil test out there. And then we combine that with the PLFA test, the phospholipid fatty acid test for biology. And then we also do some basic soil tests, and then we do water tests. And while the Haney test is by far the best one to use, we haven't had a 15-year track record using it because it hasn't existed that long. So the very first soil tests we did 15 years ago came from a lab that we don't care much about. They're not anything special. They're just a basic soil lab. But we still do soil tests with that lab. And the reason is we want consistency over time. So it's been really important to us that even if a lab isn't a very good or useful lab and they don't have anything innovative or special, we still have tests today that we can compare with those exact same tests from the same lab 15 years ago. And we've done it every year of that 15 years to see the change in time. And the change over time has been what is most impressive to see, I think. And that's really been the biggest guiding factor for how we manage our fertility here.
And it's important, we usually do them in the springtime. We have a few sets that we've done in the late summer, early autumn.
Yeah, we have a March, April window that we do a lot of tests. And then sometimes we'll do a July, August peak summer dry season, and then occasionally some October ones as well. But you want to do tests that are comparable. So if you begin doing, fields 2 and 3 in April, then keep doing fields 2 and 3 in April. And if you did field 18 in August, then keep doing some August tests. Unless you want to compare it with fields 2 and 3, then also do some April tests. But you want to make sure that your comparisons are on the same footing, on the same foundation. So it's really important to do testing in a way that allows you to gain the best knowledge from your tests.
And we're not testing every field every year or 3 times a year at all. We have a couple of fields that we, will test very often so we can see that over time. And then we'll choose a couple others like, hey, that field did really well this year, or that field has some funky things going on. Yep. And so we'll pick a couple like that.
But primarily we've chosen, 3 regions of the farm that we do tests in all the time. Those 3 regions are distinctly different from each other, and that allows us to make sure that we've hit up the 3 biggest different areas of the farm all the time. And then we can do individual tests on other fields if things don't seem to be working quite right. But that's usually not the case. It's amazing how much soil biology ameliorates those weird ups and downs that farmers can have. And that soil biology, when it's healthy and functioning, just sort of makes a general good health throughout the entire system.
And then are you doing nutrient balancing too? Or what are you drawing from those tests, and how is that affecting your fertility management?
I mean, I think up front it's pretty important to, test if you're starting somewhere completely new, like, do you have anything majorly in excess or majorly in lack?
Because actually we had some minerals that were in excess, and therefore because of that, we did not want to buy dolomite or gypsum. We very much wanted to use oyster shell calcium because we didn't want to keep adding on more of these minerals that we already had in excess. So knowing that kind of thing can be very helpful. The point of the compost is to really feed that soil biology. And if you put on, this is why nitrogen and phosphorus become an issue. It's because if you put on enough compost to meet the nitrogen needs of your vegetables, you will be putting on way too much phosphorus and potassium. The compost has a very high P and K to N ratio. And so compost is only put on enough to feed the biology, which means it may not have enough nitrogen going into the system to feed your vegetables. So our main pairing of fertility is compost and a nitrogen source like organic feather meal. That's a 1200. And those two are sort of the workhorse of feeding our biology and feeding our crop plants. But we also need to be sure to include calcium in the system, because you kind of can never have too much calcium, and nearly all ag lands are deficient in calcium to some level. And then the other thing that we're always adding in is remineralization. So any kind of,
I wouldn't say always.
Well, but that is the other thing that we are considering.
It is the other thing that we consider.
Compost, nitrogen, organic nitrogen, and then calcium, and then remineralization. And remineralization can be anything. We just use volcanic rock powder. And you can get specialized remineralization stuff. If you start to look into it too deeply, you can spend a lot of money and a lot of time getting specific remineralization things. And that's not where we need to put our effort. You can get some pretty basic volcanic rock dust and get a lot of remineralization going on.
I think where Paul and I often fall is diversity is so important. And so, diversity, get something very basic, focus on, getting a diversity of crops through there, trying to build, diversity of biology out there. And sometimes, like he just very generally said, volcanic rock dust, because we will actually switch it up and get something else out there for a little while.
And to add to the diversity list is also in making and compost. We do not use only compost we make. We do not use only the best compost we can buy. We always mix 3 or 4 different kinds of finished compost to make a new finished compost product here on the farm that we then apply to the fields. So our finished compost that we're applying has our own personal homemade finished compost in it. It has high quality purchased compost in it. It has low quality crap purchased compost in it. It has a neighbor's composted and finished horse manure in it that is from horses that are fed all organic feeds and no chemical dewormers. So we usually use 3 or 4 or 5 different finished ingredients to make a finished compost pile ourselves with 2 or 3 turnings of that finished pile.
And one of the things,
that's diversity right there.
Yeah, we really highly suggest people never use one compost from one source.
Yeah, it's never as good as mixing 2 or 3 things.
Yeah, especially because so many municipal composts are hydrophobic or can
or
burn
heavy
plants,
in carbon or salt, whatever they are.
Whatever it is.
Yeah, that's a great tip. I love that idea of mixing different sources together. I hadn't thought about that, but we often do like different types of compost, but I'd never thought about mixing from different sources. I love that. And sometimes actually we will do what I call like our nutritional compost that we'll make at the farm, like a really nice high quality compost. And then I'll just cover that with like some of that more carbonaceous stuff that we have access to as a literal mulch.
Nice. Yeah. If you're purchasing multiple kinds of compost from the same manufacturer, they use only one feedstock usually, and then they add in extra different nutrient sources to give you different products for sale. And depending on how good a quality they are, they might add in some nice quality things. Some people add in vermicompost, some add in duck manures, some add in other kinds of steer manure, but some just put in organic fertilizer. Like the only difference between the $20 a yard compost and the $40 a yard compost is the addition of $20 per yard worth of organic fertilizer. And you can buy that yourself for the same price. So do ask any composter for their tests of their compost mixes and also ingredient lists, because it's very informative. It'll really show you how they're running their business and therefore how you can best leverage your money to get compost on your farm that'll be of the right value for you.
Yeah, I think that's great advice. Well, Paul and Elizabeth, I've enjoyed this conversation so much. I just really appreciate everything that you all do and all that you put out there. And I just really appreciate you coming on today. Thank you so much.
Hey, Jesse, I have to say, I just love your podcast. I love your book. It's my number one read that I recommend to people. And I hope this has been helpful. Our conversation a couple years ago really went over a lot of the basics. This was sort of specific on a couple of things.
But I really appreciated this chance to talk with you and appreciated the chance to share some of the research that other people have done, UC Davis and CAFF, and what they have found on a no-till farm, on our no-till farm after, 10 years of being no-till, and what it looks like for the maintenance phase. We're no longer building up, we're now just maintaining. And It's been truly remarkable to see such positive returns on the scientific investigations, and we really appreciate the chance to share it through your podcast. Thank you so much.
Yes.
It makes me feel very hopeful. I think this is such a beautiful model, and I really appreciate it.
Likewise. Thank you.
All right. If you enjoyed that episode, make sure to follow Singing Frogs Farm on Instagram and all the places. There will be all the relevant links we talked about in the show notes or at no-tillgrowers.com. Some quick ways to support this work. You can swing over to no-tillgrowers.com and pick up a copy of my book, The Living Soil Handbook. Proceeds from that sale at no-tillgrowers.com go to making you more free content. Venmo us a little bit to say thank you to at no-tillgrowers, or PayPal to no-tillgrowers@gmail.com. All that works too, and we super duper appreciate it. And of course, if you have not already, or maybe if you haven't in a long time, join us on Patreon, patreon.com/no-tillgrowers. Thank you however you find a way to support our work. Subscribe to this podcast wherever you're getting it and leave a review. But this week, all reviews must say what you all have wanted to say from the very beginning. This theme music rocks. Today's episode was brought to you in part by a grant from Southern SARE. Big thanks to Jackson Roulette for all of his work, Josh Satin for the video guidance, Willie Breeding for the theme music, and of course, my amazing, amazing wife, Hannah Crabtree. Thank you all for listening and for everything. We'll see you later. Bye. I appreciate that you like the book too. That's great. I know that I put you in the deep compost category, so I'm glad you were able to clear that a little bit.
Oh, great. Everybody does it. It's okay. Compost is amazing. Compost is great. We can talk about compost for a really long time, and it is one tool in the toolbox.
Yeah.